Hello and welcome to the notes for September 13th, 2018 in Mr. Swift's geometry class. Today we're going to talk about parallel lines and how they help us with some triangles and properties in triangles. We'll begin with a postulate. Remember, a postulate is a statement that is accepted true but cannot be proven to be true. In this case, our postulate says through a point not on a line, there is one and only one line parallel to the given line. So here, if we're given line M and point P, through P we can only draw one line that is parallel to M. So I'm going to approximate that line because I don't have a ruler I can lay down here, but there's just one line I can draw through there that's going to be parallel to the given line. So I'll mark them parallel. Remember yesterday we learned that these arrows would indicate they're parallel. The parallel postulate is used to allow us to introduce a line to a picture. We can draw a line that's parallel to a given one through any point that we have on the same plane as that given line. And in a few moments we'll actually take advantage of this postulate to help us prove something about triangles. So we have a theorem known as the triangle sum theorem. You may have heard this idea before. Now we're going to actually introduce it in geometry and prove why it happens to work all the time. Notice this one is a theorem, so it is something that can be proven through a logical argument of the facts that we have and what we know based upon those facts. But this theorem says that the sum of the measures of the angles in any triangle will always be 180 degrees. So in triangle ABC, we take the measure of angle A plus the measure of angle B plus the measure of angle C. We will end up with 180 degrees. So if A was 70 and B was 91, for us to find angle C, we would substitute those into the equation, and then we would solve for angle C. So we're going to subtract 161. Now 161 is what the 91 and the 70 added to make. And we would find that the measure of angle C is a total of 19 degrees. Again, our picture shows it to look to be bigger than 19 degrees, but our pictures are just images for us to get an idea of where things are located with each other and not necessarily their size and magnitude. They're not drawn to scale. So let's take a look at why this particular theorem is true. So we're going to start with triangle XYZ, and we have line A that's parallel to XYZ, parallel to XZ. So through point Y, we drew a line that was parallel to the third one. We could do that by that parallel postulate. And we want to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Now, in this picture, we know the measure of angle 4 plus the measure of angle 1 plus the measure of angle 5, that's 180 degrees. We know that because of the angle addition postulate. Remember, the angle addition postulate tells us that angles are going to add to equal the larger angle. In this case, we have three angles. Angle 1, angle 2, angle 4, angle 1, and angle 5. And those three angles make the total of 180 degrees. Now, because we have the parallel lines, K and XZ are parallel, angle 4 and angle 2 are alternate interior, pen's not responding too well. So angle 4 and angle 2, they're on opposite sides of the transversal TX, and they're between the two lines. Now, since they are alternate interior, that means the angles are congruent, which also means that the measure of angle 4 is the same as the measure of angle 2. Now, if we were to use, let's use TZ as our transversal. So there's our transversal that intersects the two parallels. Notice in this case that angle 5 and angle 3 are on opposite sides of the transversal. So angle 5 and angle 3, they are alternate interior angles. They meet the definition of what alternate interior is. And by the alternate interior angle theorem, if the lines are parallel, those two angles have to be congruent. And if they're congruent, their measures have to be the same. So 5 is the same as 3. Now what we're going to do is to go back up to that original statement that we had. And in that original statement, we see angle 4. Well, later on we saw that angle 4 was equal to angle 2. So everywhere I see angle 4, I can replace it with angle 2. So I'm going to replace angle 4 with angle 2. I'm going to keep the measure of angle 1. Then I also notice that I have angle 5. And we know that angle 5 is the same as angle 3. So since they're the same, one can replace the other. So I'm going to replace this angle 5 with angle 3. So we substituted. We put things in for their equal. Since angle 4 and 2 were the same, I could take out the measure of angle 4 and put in the measure of angle 2. Now notice at this point, what I have here is exactly what I wanted to prove. That angle 1 plus angle 2 plus angle 3 equals 180. So we've shown that angle 1 plus angle 2 plus angle 3, those three angles which are inside the triangle add to make 180. And this is very useful, and it's one that you'll want to remember that concept. And this is the proof of why it works. So in this situation with this figure, we have three angles in a triangle. So those three angles, the 76, the 47, and the 6x minus 9, their total has to be 180. Combine the terms on the right-hand side. 76 plus 47 is 123, and take away the 9 would be 114, I believe. Subtract the 114. To find out that 6x is equal to, I think, 66. And so the x value would turn out to be 11. And our angle would be 6 times 11 minus 9. 66, take away 9. Remember, take away 10 and add 1, so 56 plus 1. 57 is how big that last angle is. So that's the triangle sum theorem. Our other theorem for today deals with things called interior and exterior angles of a triangle or a polygon. But we're going to focus with triangles here to start. So to create an exterior angle, we extend a side, and that forms an angle. And so that angle is an extended angle. So down here, if I extend this side out, I create angle 1. If I extend this bottom side out, I created angle 1 there. And if I extend this side, I create an angle. So in all three cases, angle 1 in the pictures below is an example of an exterior angle. Extend a side, and that creates an exterior angle. The other term, the remote interior angles. Interior means inside. So we want the inside angles. Remote means farthest away. A remote island would be an island very far away from here. So we want farthest away from the exterior. So in the first diagram, angle 2 and angle 3 are the two angles of the triangle that are farthest away. This other angle in here is a close one. So 2 and 3 would be the remote interior. In this picture, 2 and 3 again are farthest away. And in the final picture, they've kept the same numbering system. 2 and 3 are farthest away. So locate your exterior angle, and then the remote interior are going to be the two that are farthest away inside the triangle from that angle. Now, a theorem about this is that the measure of each exterior angle of a triangle is equal to the sum of the remote interior angles. So in this diagram, we have exterior angle 1 and remote interior angles 3 and 2. So what that theorem is saying is that the measure of angle 1 is going to equal the measure of angle 2 plus the measure of angle 3, the two that are farthest away. So if angle 1 is 55, and excuse me, let's make that angle 2 is 55. I want my two interior angles known to us. So measure of angle 2 is 55. Measure of angle 3 is 70. Measure of angle 1 would equal 55 plus 70. Add the two remote interiors together. We get 125 degrees for angle 1. Likewise, if we know angle 1, we would substitute it in to the equation. Measure of angle 1 equals measure of angle 2 plus angle 3. Realize that the exterior angle will not always be named 1, but it's always outside of the triangle. So in this particular problem, we want to find x, and then the angles. So in this case, this is the exterior angle, and these are the two remote interior. So the formula is that the exterior angle 108 equals the two interior ones added together, 15 plus 5x, added to the other one, 5x minus 7. So again, it's very much like what we've done before, solve our equations. Let's see, 5x and 5x is 10x, 15 minus 7 is 8. Subtract 8, create a 0. So we have 100 equals 10x. And so that means x is 10. So the measure of angle V would be 15 plus 5 times 10, which I believe is 65. The measure of angle U, substitute that in, it's 5 times 10 minus 7. So that would be 43. And if we check that, 65 and 43 is 108. And that matches the exterior angle. So we have the right values. And then in our last example, we want to find the value of this angle right here. And in that triangle, I know they have to add up to 180, but all we have is just one angle size. All we're told is the 55. So maybe if we work farther away. Well, in the triangle on the left, we have two of the three angles. So we can first find out, let's call this little piece here x. We can figure out what x is, because it has to add to equal 180. So 55 plus 75 plus x equals 180. So that's 130 plus x equals 180. Subtract 130, we get x is 50. So this angle here is 50. All right. Now we still don't have anything in the triangle on the right, but we are a little bit better. What do these three angles have to add up to make? They make a straight line. So that's right, they have to add up to be 180. So 50 plus 70 plus, let's call this one y, equals 180. So 120 plus y equals 180. Subtract 120, y is 60. So now we know this is 60. And we can finally move in to figure out our triangle. 55 that we knew, plus the 60 that we found, plus the question mark angle, plus the total 180. So 115 plus the question mark equals 180. Subtract 115. And I believe that's 65. So that angle there turns out to be 65. I believe that's all for today. Yep. You'll get your handout. Remember the two big ideas. The angles in a triangle will always add to equal 180 degrees. And an exterior angle is equal to the two remote interior angles added together. So you always have two pieces of information and one unknown for you to work in these type of questions. Good luck. Talk to you all tomorrow.